Rolling. Welcome. The talk today is called the Craft of TDD. Before I start, I'd like to ask you a few questions. Out of the audience, who regularly practices TDD and does it? All right, cool. And who has tried TDD but doesn't really do it that often or isn't fully convinced of the value that it can provide you? Is there anybody in that category? Okay, so some hands. And anybody that hasn't done TDD at all, but is maybe curious on what it is and how it can help and some techniques? Okay. All right, cool. So Craft of TDD. My name is Raoul Felix. I am the CTO at TalkDesk. And funny enough today, by coincidence, it's a very special day for TalkDesk because it's 5 years that TalkDesk was incorporated as a company. So happy birthday, TalkDesk. Thank you. So what I've got prepared for you today is divided into two portions. The first portion, I'm going to try to convince you of the value that TDD can bring to your developer's life. And then the second one on actually writing tests, which you're going to be doing a lot if you do practice TDD. So as developers, what is our goal? Well, one of our most important goals is to deliver value to our users, right? How can we do this? Well, by delivering working software faster to them, by adapting to requirements that will inevitably change as time goes by and new things that come into people's minds and we have to adapt, as well as producing software that ideally has the less amount of bugs as possible. So you should be doing TDD, and TDD can help you with these aspects, but it should in the sense that, as in the RFC, highly recommended. However, if you do decide that it's not the right course of action, you have carefully weighed your decision on why to do that. So what can TDD provide us in terms of delivering software faster? Well, for starters, you can think of TDD as being a productive workflow for you as a developer. The usual cycle of TDD, is red, green, refactor, which means you're writing your tests first, you're seeing them fail, you write enough production code to get them passing, just enough, and then you refactor the code. So you start to get in the cycle, you start working, you start to get in the zone, you start ignoring the mechanical keyboard of the person next to you, or maybe the horrible kizomba music blaring on the other side. So you just focus, you're writing your tests, you're writing your code, you're refactoring, and you're doing this, and you go all day, and you're really productive. So it helps you also get into the zone. And another interesting tip is to end the day, or maybe before you go to lunch, leave a failing test so that the first thing you do when you come back, implement the test. Like that, you're able to get into the zone a lot faster. You get context a lot quicker of the problem you're trying to solve. It can also facilitate working in a team. How? While you're writing the tests, these tests can serve as documentation, so they're really reliable. I probably won't lie as easy as code comments do. And so it helps you understand what somebody else or what your past self did. It can also help you detect conflicts. So you have this test suite, which you run often. And so maybe you're changing a portion that another teammate of yours is doing. You're going to see the tests fail. It will give you an opportunity to go and speak with them and sort that out. TDD can also help you lower maintenance costs by allowing you to catch bugs earlier. How? Well, because you're writing the tests first, you're thinking about the problem beforehand. You're thinking about the edge cases, so you're usually already writing in the production code to handle these scenarios. It can also help you debug issues a lot faster because usually when practicing TDD, your end result is a lot of smaller components in software which have smaller responsibilities and are easier to understand. So when a problem does arise, because it will help you to locate the problem a lot faster. So that's how TDD can help us deliver software faster, but how does it help us in adapting to user changes? Well, it helps because it can help you produce a better design. How so? Writing tests first, your tests become the first users of your API, of your production code's API. So you're getting a sense of how easy it is to use that design. And so there will be times where you're writing a test and you're going to feel the pain, you're going to feel some resistance. You should take that as a signal that there may be something missing from your design or something that's not right, and you should try to take that opportunity to refactor your code so that pain can go away. Doing this will usually result with code that has a lot less coupling, because with highly coupled code, it usually means that your tests are very big and hard to understand and hard to set up and actually run. So it does this because you're getting this immediate feedback. You've got these tests, these unit tests that you're running very often, so it's important to keep them really fast so that you keep on running like every minute, whatever, as soon as you can. And because you're doing this, you're actually able to have confidence when you come and change the design, because you felt this pain, you want to change it. So you make the change, but you're not worried that you may break some other functionality in some other side of the code that you may not know just yet. So unfortunately, we aren't guaranteed good design when using TDD. Sure, it can get to a better design, but it may not necessarily be the best design available, because we didn't really go from a big upfront design to no design at all. So TDD is mostly in the middle, emergent design. However, it doesn't emerge from nothing. It doesn't emerge magically. You have to think about your design first. You have to actually, like Ron Jeffries, the co-author of, one of the co-authors of Extreme Programming says, act locally in your TDD cycle, but then refactoring, think globally about the design of your solution and what it is you're trying to accomplish. But I mean, what is good design? So just this can provide a talk. So good design usually is one that can follow the solid design principles, but just these design principles can give a whole talk. So I'm not going to speak about them all, but I will reference a few of them. So what does solid stand for? The S is for the single responsibility principle, the open-close principle, Liskov substitution principle, interface segregation, and dependency inversion. However, I just want to show you two examples of these principles, the single responsibility. So take this class over here, this IP class that has this method, which will classify if an IP is even or odd. I do apologize, this is a very contrived example, but it was the best I could come up with at the time. So we write the code because we need to communicate with an external service in order to identify what our IP is. And then we take that IP, look at the last segment of that number, and we determine whether it's even or odd. How many responsibilities does this class have? How many reasons to change? So if ever something had to change regarding the API that we're using, be it changing the URL, adding authentication, maybe adding a parameter, we have to go to this class and change this portion of the code. If we need to change the way we classify what an IP is, maybe we don't want even or odd, maybe we want fizzbuzz, well, we have to go to this class, the same one, and change this portion of the code. So this one is easy. You can extract these two responsibilities. One that's just responsible for actually communicating with this external service to identify your IP address, and another one that actually provides the classification. Now, the other one of the principles is the dependency inversion one, which is pretty interesting. So looking at the same classification of the IP code, this is the code that we saw, and we can imagine this being a test for the code above, where you're just calling the classify IP, and it will run, and we expect it to be even. So there's a big problem with this code. One, it requires internet access, so if you do not have internet access, this won't work. Another one, you have to be really lucky because your IP at that time has to be even for this test to pass. If it's odd, this test will inevitably fail. So this is actually more of a problem of the test, but it's just an example to show you next. What can we do to, in this case, make it better? So the dependency inversion principle says that we should depend on abstractions rather than concrete objects. So this classify IP call method actually depends on this what is my IP address service. However, if we instead depended on something more abstract, so we're just depending on an object that replies to the my IP method, then this can help us because now we can create a test where we are actually injecting a stub. The stub always produces the same IP that we determined as being even, and thus our tests can run even without internet access and in a more reliable fashion without sometimes failing. And by doing these two, using these two principles in the code that we just saw, we are gaining additional flexibility. So we are able to change, adapt to changes in requirements. So for example, to maintain everything the same, this piece of code will continue to use the exact same service that we did have previously. However, maybe some other new service comes along that's more reliable, that's faster. It's okay. We can create another wrapper. We can inject it into the classify IP call. Maybe now another requirement comes that this service actually costs money, and we want to cache the responses so that we don't get charged as much. Still okay, because we can use a decorator class around the IP service that will persist the responses to Redis or something like that, and we just inject it into the method call. So another aspect of good design is that it follows the 4 rules of simple design as defined by Kent Beck, one of the major influences of TDD. What he says about the 4 simple rules of design is that 1, your code always passes all tests. So your tests are always green so that you can have confidence that they are working, that your code is working as expected. That your code reveals the programmer's intention, that it's explicit and that you understand what's going on. That there is no duplication of concepts in your code, so that everything has like one responsibility and that you know where to go when you need to understand something. And the simplest design is obviously one that has the fewest elements, so it's the most easiest to understand usually. Another aspect is, good design tends to favor a separation of concerns. So there are examples of architectures that use this, where you have various layers that divide objects into specific responsibilities. And one of them is the clean architecture. So unfortunately, I cannot delve deeply into this because this is just another talk, completely separate. But then also the hexagonal architecture. So these are 2 examples of things that favor separation of concerns. And that is how TDD can help you adapt to user changes by creating a better design. But how can we produce better software because of TDD? 1, by writing tests first. Why? Because it actually forces you to think about your code first. So just the act of you thinking before you actually write in production code will increase the quality. So this is not something that is exclusive to TDD. Just thinking before can certainly increase the level of your production code. However, TDD incorporates this in the practice, and it's an easy way for you to follow and gain this. By writing these tests first, you're also defining what you want, the behavior that you want, which helps you to avoid tests that are fragile. What are fragile tests? Ones that where you change some production code and for some reason your tests start to fail unnecessarily. TDD can also help you produce a test suite that has a lot of tests that will help you form a safety net for the changes that you will continue making. And there are actually various styles within TDD that you can use to come up with this test suite. The one that's probably one of the most known styles of TDD is what's called the classical Detroit style of TDD, where the idea is that your unit tests will actually use real collaborators when possible, and only in circumstances where it's odd, so maybe you have to interact with a mail service or something like that, will you actually stub that dependency out. What does this look like? So another really strange example. So the say hello class, where we expect that the method call will provide us a greeting, right? We want it to give us a greeting, and then we want it to format the name that we provide. The implementation for this test is something as simple as this. So that was a red, now this is a green, this will get the test passing. Now it's time to refactor, right? And using the solid design principles, maybe we look at this piece of code over here and we decide that, hey, there's actually 2 reasons to change: the greeting itself and the way the name is formatted. So we go ahead, we refactor the code, we create a new collaborator, the capitalized formatter, that just does the capitalization of the name, the formatting of the name, and we update our say hello class to use it. So notice how now the test, which uses the say hello class, is actually using a real capitalized formatter. So it's actually using a real collaborator. And so these types of tests are also known as sociable unit tests because they're actually socializing with real objects. The other style of TDD is known as the Marxist or London style TDD, where it changes the way you think about how you do this. So you're thinking more outside in. Using this approach requires you to have a bit more design sense. Why? Because when you're writing the test, you're already thinking about the type of collaborators that your code will need to actually do its work. So you look at this unit, you define, okay, it needs 2 collaborators. Now you go drill down, you're on this other lower level unit. What collaborators does it need? It needs 1, until you get to a point where you do not need any more collaborators. You write the tests around that and you go back up and backtrack. An example of this is the same one. So we want to say hello. But now we say, okay, we want to provide a greeting, but we also know that we want to format the name in a particular way. So we're going to need a stub that will be able to give a name and produce us this formatted name. We obviously have to find a way to inject it into the call method, and we have the expectation as usual. And then the code that we produce is very similar to the end result of the Detroit style version. But notice now how, in this case, the say hello class that is used in this test is not communicating with a real collaborator. Capitalized formatter doesn't exist anywhere. It's actually just using a stub. And these types of tests are usually called solitary or isolated unit tests because they do not actually work with real collaborators. So you may be thinking now, okay, which styles do I use? Well, you will inevitably end up using both styles to help. The Marcus style approach tends to give you more feedback on your design because you are creating these fake collaborators that do not exist yet in code, which gives you more flexibility to change their design. So you're understanding that this API I'm defining for the capitalizer, whether it's appropriate for the problem or not. And that is how TDD can produce quality software. And this brings me to the end of the first section of the talk. And hopefully you are convinced more on how valuable TDD can be for you. But now, on writing tests. So you're going to be producing a lot of tests. So some people wonder, how many tests should I produce versus the others? So looking at the testing pyramid that Martin Fowler came up with, it says that at the base of the pyramid, we'll have your unit tests. So this is the number of tests that you'll mostly end up with, because they're a lot faster to run, a lot more reliable, and they're the ones that are giving you the feedback about your design and providing you a safety net. But then you need to know other types of tests, like integration tests, to test gateway objects with communications with other services, databases, and then you move up to acceptance. So the further you move up this pyramid, it probably means, it's the less tests you'll have. Why? Because they're probably a lot slower, they're probably a lot more fragile, so sometimes they will break, but it may not necessarily be because of a problem in your code. Maybe some service didn't launch in the time window that was expected, or some API is down. And so there. So use the testing pyramid to help guide you on the number of tests that you will need. And now to the tips. Tip number 1, test as little as possible. This is a bit odd. No, but test as little as possible to give you the level of confidence that you need for your code. So if you're using the say hello example, once again, you've got this code that we're using the capitalized formatter, and we've also got the capitalized formatter code that does the formatting. So now we're going to look at the tests that we have. We've got the say hello test that's using the real collaborator, right? And we've also got a test for this capitalized formatter because we want to make sure that, given a name, it will actually capitalize it. But notice how these two tests, the way they are written, they are basically the same. One is implicitly doing it, but they're both checking that, John is actually being capitalized. So by me having these two tests in my code, though I have more confidence that it works. Maybe if I just had this one test, I'm still as confident as I was previously. So why not just have this one test and that's it? Which leads to tip number 2. Always ask why you're writing tests. What value are your tests providing you? Are you writing tests to help you verify behavior of your system? Or maybe are you trying to write them to enable safely refactoring when you're working with others, creating that safety net that you need? Possibly it's because you want to have your code being used as documentation. Maybe you want to get immediate feedback from the design of your code, or possibly just to know when you're done so you can go home and drink some beer. So always ask why, and do not be afraid of actually removing tests that end up not providing value to you any longer. Tip number 3 is, 100% code coverage shouldn't be your goal. Why? It's simple. So using the simplified version of the say hello greeting, if we were to have this class right here that just does the method call, code coverage would be 100% because we're attacking all lines. But does this test give me any confidence in the behavior of the system? None at all. So if you do follow this path of trying to reach 100% code coverage, it means you're going to be doing some really strange stuff in your tests. You're going to be testing weird framework code, which probably doesn't need to be tested because, hopefully you're using a framework that actually has its own tests. So, tip number 4 is that your test should follow a consistent structure. Why? Because it's important for you to easily look at a test and understand what's going on. So usually tests can follow the AAA, the arrange, act, and assert. I went through that really quickly, but so you're edging your test, you're doing the setup, you're acting on it, and only then do you actually do the assertion. But when you're using mocks, it's still AAA, but it just changes the order. So in this example, we continue to have the arrange part where we're setting up the mock. Now we are asserting, we are defining the expectations on the mock, and then we are acting. Tip number 5 is definitely to fix your flaky tests as soon as possible. So if we were to look at this, another contrived example, we have this application which uses a class variable to store the current username. And we have a corresponding test that will make sure that by default, there is no signed in user, right? It's null. But now we have this other class which will actually log in the user, and it just updates the current name of the application to be the user that actually logged in. And we have the corresponding test that confirms that this alteration is done. If we were to run the app tests first and the login user second, everything's okay. The tests will pass. If we were to run them inversely, well, unfortunately now we have a problem because our tests will fail because we are mutating global states. Sure, we definitely want to avoid global states precisely because of these issues. And it's even worse when your tests run randomly because sometimes they will fail and sometimes they won't. And the problem when you have tests that sometimes fail and don't is that you start getting blind to the red tests, right? So there will come a time where your tests are crying wolf too many times, and you'll just ignore this red test. And in reality, it's actually a real issue that's in your production code that will then be shipped to your users. So that's why you want to always fix those flaky tests. Tip number 6, keep your tests damp. What does damp mean? So damp means descriptive and maintainable procedures. So you want to keep your tests damp, but your production code dry. Why? Well, if we think of our tests as these tiny little universes that we are actually setting up, we're creating, we're defining their behavior. They have their specific purpose. We want to assert particular behavior on them. These are like mini independent applications running in the tests. Whereas in an application, when you run it, it's just a single unit that has a particular purpose. And so in there, you want to keep everything dry. But in your test, because there are multiple independent units, you actually do want to permit a little bit more duplication there because it will help you understand your code a lot faster. So when you look at a test, you don't have to jump around 10 different files to understand what does this helper method do, what does that helper method do. You just look at it straight away and get an understanding of what's going on. Tip number 7, so watch out for fragile tests. What happens with a fragile test? I mentioned that when you have production code that you change, you're just changing behavior. It causes your test to unnecessarily fail, which makes you kind of want to hate changing production code, which is not a good sign. So you always want to be able to have the liberty to change your code. This usually happens when there's a tight coupling between production code and your testing because of when tests actually mirror their implementation. And this is very easy to occur when you're actually writing tests after the fact. So imagine we had another example of adding money to accounts where we actually receive the amount in cents, we convert it to dollars, and then we increment the account's balance. So we wrote the production code first, and now we want to test, right, that this code works as we expect. So writing the test here, we create our account's balance with an initial value of $10, and now we use mocks to make sure that we create a dollar using the right amount because we're giving cents, but we actually want to make sure that it's $5. And then we make sure that the balance is 15 at the end, and we do the code. So notice that we are creating this. Now we're doing other code right, and we look at other portions, and we understand that there are other places that want to actually convert cents to dollars. And so we go ahead and we factor this into a helper method from cents, but now we have a problem. Our tests break. If we were to deploy the code as is, the user wouldn't notice anything, everything would continue to work, but yet for this reason, that we're actually creating expectation around new, does our test fail unnecessarily. It's a false negative. So what you want to do is you want to test behavior. You want to think of the behavior of your system. So if we were to change that test a little bit and just act upon the method call and then just assert at the end whether the final balance was 15, this gives us the flexibility to do the refactoring, and our test will continue to pass as is. So watch out for when your tests are almost a one-to-one match of your implementation code. Tip number 8 is to avoid over-isolating your code. Why is this bad? Well, we can use this example here with the stub on the formatter, right? We are creating the stubbed formatter. We are introducing it to the test. Now we've got this hello class that we've defined, but we've also got this capitalized formatter that we've already seen. But now for some reason we decide that we want to refactor and we do not want to call this method format anymore. It wants to be pretty format. So when we run these tests, they will continue to pass. So it's a false positive. Why? Because this test is only using a stub. So it doesn't actually notice that there was a change in the method name. How do we protect ourselves against this? Well, in Ruby, which is what I know well, our spec has a thing called verified test doubles and only requires you to change that way you declare the test double by saying that you want an instance double and you actually provide the class, the capitalized formatter. What this means is when you run this test by itself, this will act as a pure stub and it will continue to pass in the example I showed you. However, if I were to run the whole test suite, where it actually loads up this capitalized formatter class, it will actually provide you to say, hey, there's an error, because it will check the interface of the actual real-life object and alert you that there was a change. When you don't have this, and you're still working in a dynamic language like Ruby, the other solution you have is to mix solitary unit tests with sociable unit tests that can give you that confidence that you may need to make sure that your unit is actually working and can collaborate well with its collaborators. So second last tip, only mock what you own. So why is this important? So imagine another example where we want to charge an account and we're using Stripe's wonderful API. Now we create a test around this where we actually are now defining an expectation around Stripe's API. So this is an API we do not have any control of. They're their library, their Ruby library. And so if someday they do, so we've got other tests, we're testing other edge cases, so this expectation is repeated in those various tests. But now all of a sudden, for some reason, Stripe decides to change their library and instead of create, they want to say, call it new. Those 5 tests that have the same expectation will start to fail unnecessarily. One way to, and we'll have to go to each of them and now update it to conform to Stripe's API. One way around this is to wrap this Stripe's API into an object that you own with an interface that you control. So in this case, it's the credit card gateway, which we have a charge method, and internally it will use Stripe. There will be another corresponding integration test that I don't show here that will actually maybe use Stripe directly and perform the integration test to make sure that that is working as expected. But when they do change their API, it's okay. Only that those tests will fail, and there's only one place where I need to change, which is the credit card gateway. And the final tip is, well, it's not really a tip, but TDD isn't a magic bullet, so definitely suggest to write more tests for those critical sections of your code where you need more confidence, and to especially invest in additional testing techniques that may not naturally occur when doing TDD. I'm going to show you some of these techniques. One of them is mutation testing. Really interesting. How does it work? So going back to the classify IP test, where we are actually defining the stub with a static IP, we know that it will always be even. What mutation, the corresponding code here that actually implements it. So what mutation testing does, it analyzes this code, looks at the various branching statements and things like that, and it's going to go ahead and it's going to mutate those conditions, right? It's going to change that equal equals to a non-equal. It's going to run that same test again, and if your test passes, it's going to alert you. It's going to say, listen, I changed something in your code. Your test should have broken, so maybe you're missing an edge case that you should definitely consider. Property-based testing is another testing technique that can definitely help you out. So how does it do it? So this is actually used in Haskell with a quick check. So it's very common. What it does, it generates different input and runs your code with lots of different inputs to see if there's something that will break. Using the same example, we still have our test, but instead of using that static IP, we are actually defining a property. We want an integer, which is always divisible, by 2, so it's even. And we take that number that this test will generate, and we use it to create this IP address, and we have the test as normal. So instead of us just using one IP address as a way to confirm it's even, it's going to generate various examples and try and find one that can possibly break it. The final testing technique that I found very interesting and that we also use at TalkDesk is consumer-driven contract tests, which is very useful when you have lots of internal services where you control the client and the consumer of the APIs as well as the producers of the APIs. So when you have these services internally, you've got your producers that provide an API and has their own test suite running. And what happens with this consumer-driven contract test is that the clients define the expectations they have over your API, and those expectations are actually included as a part of the test suite of the producers. So when you're developing the service, the API, you can actually run the tests, and you'll understand when you've actually broken expectation of one of your clients, so that you can then go speak to that team to understand why this breaking change has to occur. Maybe there's another way to go around it. And that's brings me to the conclusion of the talk. So there are a lot of benefits to TDD in helping you to deliver software faster. It can help you adapt to user changes by helping you achieve a better design, but you need to accompany this with your own investigation into what it means to have a good design, as well as having ways to help you produce quality software by producing a test suite that can help you gain confidence in doing the changes. Obviously, there are disadvantages. Writing these tests this way and writing tests in general is the skill that you need to learn and get better at. So there's always a little bit of overhead. It doesn't resolve every design problem that you will have in your code, so you have to invest in that as well. It's not going to design every testing problem, so that's why you need to look into other techniques. And some things cannot just be TDD'd, so if you just don't know what result you're expecting, like you're generating some random images for some reason, it may be hard to TDD that type of thing. And then we've also looked at the various tips. I definitely want you to focus on at least two of them, testing as little as possible to give you the confidence that you need, and then always ask why and never be afraid to delete a test that has stopped providing you value, and to invest in other testing techniques as well. And so this is bringing me to the conclusion of my talk. I did come up with a whole bunch of references. There are certainly must-reads that are at this link, and then additional blog posts that will keep you entertained for quite some time. If, like me, you will end up with 400 articles in Pocket that you need to read, but it's another problem I have to solve. I've also created a channel in PixelCamp Slack called TDD. So I have a few different people there. It's pretty great. I definitely would welcome more people there to maybe talk about TDD in general and things like that. I'd definitely be able to help you out there. But if there are any questions now that I can answer, I'd definitely be happy to. So, thank you. Questions?
Hey, hi. So property-based testing, awesome stuff. You had an example there in Ruby. Is that actual code or is it mock-up? Is there something to do that in RSpec?
So are you talking about the property-based one?
Property-based, yeah.
So most of the code that you saw here actually does run. I do confess that towards the end of the slides, I started just coding in Keynote. So I did actually look at Runtley's specification. I've never personally used it, but I did try to simulate it as closely as possible. I did identify an issue there in that test, because an IP address will only go up to 255, and that's generating more numbers. But yeah, so theoretically that can more or less work like that, yeah. There are other libraries for quick check type implementation. One of them is Runtley, the other one is Proper in Ruby.
So in one of the examples that you showed about billing, you're saying the problem of mirroring the implementation, the test mirror implementation. So how do you deal with code that has inherent side effects? Because in that example, essentially you were checking the return to see if it was right, but the other part of the code, the part that was tied, was about checking if the side effect was being applied, if the account credit was being set, I think, or something like that. So, and you replace that part with something more abstract. How do you deal with these side effects more often?
That's an interesting question. So you can definitely use stubs and mocks here, but as long as they're your objects that you own to help out. And then you need to accompany this with integrations tests. So actually, even today, I was looking into more information about the humble object pattern. So this is one of the links to a blog post in the resources over there. And it actually describes a very interesting technique where this humble object is something that's really, really simple. It's so simple that it almost needs no tests. And this can basically be the adapter to this integration, so Stripe's API, for example. But then you actually have something that you do test, which is the builder that will create the response. But then, yes, so you can then just use a stub, but then you're actually then checking that you're imitating a response, but then you're then checking the side effect that it will produce eventually in your code. But you don't have to worry about speaking to Stripe or anything like that. I don't know if I answered your question exactly, but anyone else? Questions? Interesting.
Yeah, chaos. Right now, like the people are getting more and more into microservices. Have you thought about like chaos testing or failure testing, where you have like some components, some microservices, and then just randomly decide just kill one of them and see how the system behaves?
Sure. So, interesting question. I'm having a bit of a deja vu here. So chaos testing that like Netflix does, very interesting. So like I mentioned, TDD doesn't solve all the problems that you will inevitably have when you're creating code. So what chaos testing there with things like Chaos Monkey is doing, it's helping you gain confidence on the resiliency of your system. So you have these systems, you start bringing them one down, each randomly in a random order, but you want to maintain that your service is actually continuing to run. And so you probably have some like smoke tests or end-to-end tests that are running when you're actually turning down these services. So I'm sure these tests are pretty flaky. So obviously you don't want to have a whole bunch of them, but definitely, I think it definitely fits in that smoke or end-to-end portion of the testing pyramid, and definitely something that you can do in order to gain confidence in the resiliency of your system when services will fail, because they will definitely fail one point or another. Okay, any more questions? No? So if anything comes to mind, I'm in the channel. Definitely reach out. Other than that, thank you.